What's going on, y'all? Welcome back. We are continuing our discussion in Math 48A of Lesson 9 handout. We're moving on to problem 7A, which is to solve this radical equation using a graphical method. I'm actually going to leave this as a challenge problem for you all. We just did a video about problem 6A, where we used our graphing calculator to fill the table out. We graphed the left-hand side, we graphed the right-hand side, we found the point of intersection, and we said that the solution to this equation is the x-coordinate of our point of intersection. So go back and watch that video if you haven't done so, and then you can recreate that mechanism to solve this problem. So it's a little bit of a challenge problem for you. What I wanted to do next is actually show you the algebraic version of this solution. So when you finish the graphical method, problem 7B suggests an algebraic technique to solve the same equation. Before we dive in here, I wanted to show you a resource that might be a little bit helpful. So specifically, let's go over to the Math 48A homepage, which is appliedlinearalgebra.com/blog. So if you just go to appliedlinearalgebra.com, click on the blog button and go over to the right-hand side, Math 48A. Scroll down a little bit, you'll have all of my lessons. You'll have some YouTube videos here that's useful. What I wanted to show you, though, was right here. There's this thing called Conquer College. This is kind of an 8 or 9-year-old project that I have, which is to show students some of the skills that we use in college math classes. If you click on Conquer College, that leads you to my Conquering College website. And then what we're going to do is scroll down to the Study Skills Activity 5, which is how to use suggested problems. It's the one that you see right here on screen. If you click on the actual link right there, this will download a PDF copy of a handout for you. And what I wanted to show you here is some ways to write math. So specifically, we have 2 different mechanisms. So if you go in that handout, you can read through this. There's a lot of suggestions on some study skills for learning mathematics in college courses. If you go down to pages 3 and 4, this kind of shows a useful way to track your work in math classes. So a lot of times, if you're working on an expression, to simplify an expression, we start with the expression over here. We do an algebraic step and get to an equivalent expression. Equivalent expressions are connected with an equal sign. If we do some more algebraic work, we'll get to a third equivalent expression. And then eventually we'll get down to what we call a simplified expression. What I like to say is, when you're doing these type of manipulations, we start with our first expression, and then we use a chain of equivalent expressions that are connected by equal signs, all lined up. Notice I like to suggest that there should be some space in between these so that it's super easy to read. Most of this is just tips on how to do math without making silly errors, and so that you can track your work. You'll see that I do this a lot in my videos. The page 4 of this actually shows equivalent equations. So equivalent equations is if I start with one equation and I produce another equation that is equivalent to the first one, I connect that with what I call an implication sign. An implication sign is 2 lines with a little arrow. So notice if I start with equation 1 and then I produce equation 2, I connect that with a conditional arrow. And then I literally just continue to connect that until I get down to the solution to my equation. Notice that it's the same format, but instead of an equal sign, we use an arrow. And then again, we're skipping space here. And the reason that I wanted to highlight this, well, actually I had 2 reasons. Number one, I wanted to show you this document. This thing took me about probably 10 hours to write, and it's there for you for free. It's all about how to write math in a way that makes it easy for you yourself to understand. And then not only do we have this document, but I'm going to keep this up in the background to actually demonstrate this principle of writing math in action as we solve this problem. So we're going to actually use this structure to craft our solution. So here we go. Let's go ahead and write this. So here we're going to start with this equation. And one of the other things I really love to do when I write math is actually write the full equation down in my own handwriting. So the first thing I do is I just write the normal equation that I started with in my writing, which is 3 plus the square root of 5 minus x. And on the right-hand side, we have x plus 4. So this is equation 1, right? So over here, I've got equation 1. And then what am I going to do is create an equivalent equation and connect it with a conditional statement. So here we go. Let's go ahead and do that together. So first thing I see is I want to get the square root by itself. So I'm going to actually subtract 3. If I subtract 3 on the left-hand side, I should also subtract 3 on the right-hand side, because anything I do to the left-hand side, I also do to the right-hand side. Notice that 3 minus 3 is 0. So that term goes away. I'm going to write an equivalent equation, the same relationship, but written in a different way. So now on this side, the 3 went away. On this side, I have x plus 4 minus 3. 4 minus 3 is 1. So I've got x plus 1. This is a square root. Notice I'm giving myself a lot of room between those particular lines so that it's super easy to read. So now I want to get rid of the square root because that's kind of a headache. Well, the opposite of a square root is a square. So in other words, to undo square roots, I'm going to square the darn thing. Let's go ahead and square this. If I square the left-hand side, anything I do to the left-hand side, I must also do to the right-hand side. So in this situation, I'm going to say that this is x plus 1 quantity squared. Well, we know that when I square the left-hand side, the square and the square root cancel out. Those are inverse operations, just like positive 3 and negative 3 cancel out, or subtraction is the opposite of addition. So too, squares are the opposites of square roots. So in this situation, on the left-hand side, I have x 5 minus x. And on the right-hand side, anytime I square something, I literally just take that thing and multiply by itself. So here on the right-hand side, I take x plus 1, and I just multiply x plus 1 by x plus 1. And then this is where a lot of my students will say the word FOIL, or saran wrap, or some mechanism. So FOIL means first, outer, inner, last. Now, I'm not against that idea. I tend to like to do FOIL by distributivity. So this is an addition, that's a multiplication. So I can pass that multiplication inside the addition. So this is x outside of x plus 1. And then this is plus 1 outside of x plus 1. Now I'm running out of room. Anytime a mathematician runs out of room, rookie mathematicians will try to write all their stuff on the bottom and get all mucked up because they can't read their own writing. Professional mathematician, when running out of room, just go ahead and grab a brand new sheet of paper and start over. So here, not changing anything on the right-hand side. So I've got x. X times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. And I believe my son is awake. Really like to finish this. Let me go ahead and lock him out. Early in the morning before my kids get up, and they just woke up. So here we've got x squared plus 2x plus 1. Okay. Well, now this is what we call a quadratic equation, and I will actually show you some resources that you can use to solve quadratic equations. I have some nice videos on that. What we're going to do is get the left-hand side equal to 0. So we're going to subtract 5 here and subtract 5 there. So now we've got, and then we're going to add x and add x. So now on the right-hand side, 5 minus 5 goes to 0. Sorry, left-hand side. Negative x plus x goes to 0. So here I've got 0. And then here I've got x squared plus 3x minus 4. We do a quick recall. This is what we're going to say is in standard form. So we say remember that standard form of a quadratic equation is 0 ax squared plus bx plus c. That's what we call standard form of quadratic equation. And specifically, we see that a equals 1. The number in front of x squared is 1. The number in front of x is 3. And the c value in this case is going to be -4. So we're going to factor using the AC method. Okay, in the AC method, we literally write a times c up top, and we write b on the bottom, and then we want to find two numbers that multiply to a times c and add to b. So let's go ahead and do that. So when we write this, multiply, well, 1 times -4 is going to be -4. B down here is going to be 3, so this is going to be add. And then we want to find two numbers that multiply to -4 and add to 3. Well, I can immediately see that that's going to be +4 and -1. So what I say is +4 times -1 is -4, so that checks out. And then I know that +4 plus -1 is 3. So the reason that this is really interesting is now I have just found out that +3x I can write as a +4x minus x. Okay, the reason that that's interesting is if I look at my original equation, which was 0 is equal to x squared plus 3x minus 4, well, I can do something called split the middle term. I had a lady in my 105 class years ago that taught me this. I'd never seen it before. So my Math 105 students taught me. So 3 becomes +4x minus x minus 4. And then what's really nice about that is we're going to do something called factor by grouping. So this thing is going to be known as a factor by grouping. So here we're going to say that this is x outside of x plus 4. And then notice, so the first two terms we group together. And then we're going to group the second two terms together. Notice in the second two terms, I can pull out a -1. And if I do that, I get an x plus 4, which implies, so this is an equivalent equation, I actually have these two groups of x plus 4. So if I factor those out, I get something that looks like x minus 1 times x plus 4. Okay. Well, anytime we have a times b equal to 0, we say that that either means that a is equal to 0 or b is equal to 0. That's called the zero product property. So if I think about this, here I've got something that looks like a times b is equal to 0. So I can either say that x minus 1 is 0 or x plus 4 is 0. Well, if x minus 1 is 0, I can get rid of the 1 by adding it. This would mean that x is 1. And if x minus 4 plus 4 is 0, I can subtract 4, and I see that x is equal to -4. So those are two possible solutions. But remember that the original equation looks like this. So we want to check whether or not the solutions that we generated here actually solve the original equation. So what we're going to do is actually check that. So let's go ahead and just remind ourselves. So let's check the x equal to 1 situation. So if I do the left-hand side, everywhere I see an x, I'm going to put in a 1. So this is 3 plus the square root of 5 minus x, well, we said that x was 1, so this is 3 plus the square root of 5 minus 1, which is 3 plus the square root of 4, which is 3 plus 2. Okay, let's check the right-hand side. The right-hand side would be x plus 4. Everywhere I see an x, I'm going to put in a 1. So this is 1 plus 4. Oops. Which is 5. So notice that 5 equals 5. So what we've just confirmed is it looks like x equal 1 is a good solution to this particular problem because it actually works out. Let's check the other one. So what we'll do is we'll check x equal -4. So let's check the left-hand side first. We've got 3 plus the square root of 5 minus x, which is 3 plus the square root of 5 minus a -4, which is 3 plus the square root of 5 plus 4, which is 3 plus the square root of 9, which is 3 plus 3, which is 6. But if we check the right-hand side, which we said was x plus 4, everywhere we see an x, we're going to put in a -4. 0. Notice the left-hand side doesn't equal the right-hand side for this particular value. So no, not a solution. That's called an extraneous solution. So specifically, when we go back into this mechanism, we say that this thing is extraneous. And there's some really deep questions about why that's the case, but that's how we solve that type of problem algebraically. The last thing that I wanted to say is that some of you might be wondering where I got that AC method technique from and how you could learn more about it. So what I'll do in this situation is actually show you a resource that I share with my students. Let's go back to our Math 48A website. So again, if you go to appliedlinearalgebra.com, go over to blog, go down to Math 48A. Over here, I've got this Math 105 website. I've taught intermediate algebra many times. So if you click on that Math 105, that's an intermediate algebra class, you'll see that there are a bunch of resources. And in fact, right here in lesson 3, I've got what I call a lesson 3 handout, as well as full solutions. And then I've got a playlist of me doing YouTube videos, very similar to the one that you've just seen here. So if you click on this thing, this will actually lead you through an exercise of a bunch of problems related to the zero product property and factoring, as well as the graphical technique, which we've seen in other videos in this class. For those of you that want to follow along, there are full solutions available for you that you can download and check your work. And then this is kind of cool that if you click on this thing, this is a playlist made by yours truly. So this is me audibling resources to help you understand how to factor. And specifically, we see lesson 4, there's also more general factoring, and you can download all of those with corresponding videos. I have not yet finished my videos. I've gotten through lesson 3. And then these right now, at this moment, this is February 18th in 2021. At this point, I have not finished these videos, but I plan to do that at some point in my future. Anyways, the reason I wanted to show you that is if you wanted to learn more about what the standard form of the quadratic equation is, why we set the left-hand side equal to 0, how the AC method work, those resources on that Math 105 website will kind of walk you through that. Okay, great work, y'all. I'll see you in just a little bit. Take care. Bye.